Okay, now having eliminated the variable a from our original system of equations, matching up the coefficients of a, multiplying equation 3 by 2 so that it'll match, so the coefficient of a will be equal and opposite to that of equation 1, adding that to get this equation, then multiplying the second equation by -2 and the third by 3, which matches up the coefficients of a, one equal and opposite to the other, and adding the two equations, we get our second equation. Then adding -13 times the first equation to the second, we match up the coefficients of b, they go away, we end up with just an equation in C, and we easily solve that. Now what do we do next? Well, the next thing we're going to do is we're going to take this value of C and plug it into one of these two equations. I'll go up to the top one here. Okay? Now that gives us the equation. I'll write it down here. So now we have the equation b minus 4c. C is 40 over 32, 33. So we simply replace c with 40 over 33, and then we multiply everything by the common denominator. We get 33b minus 4 times 40 equals 33 times 3. And I prefer you not skip the step by multiplying the 4 by the 40 at the same time. You multiply the 33 again because almost everybody has very limited skills with fractions. So that gives us 33b minus 160 equals 99. Well, we're going to add, and you really should write out every step, the plus 160 and plus 160 and so forth. And we get 259. Now I hope I'm doing the arithmetic correctly. We're going to check. Okay, so I'm being kind of careful, but I know I'm going to check whether I'm careful or not. So I don't go to too much trouble to be too careful. I can overdo that since I'm going to check, and I think I'm going to come out all right. And you know that I don't always. I'm going to run through this and not be all that meticulous. You got to judge how meticulous you are. As long as you're checking, you'll find out how to balance being meticulous in your equations with occasionally getting a wrong answer. Okay. Anyhow, b is 259 over 33, and 33 is 11 times 3. 3 doesn't go into 259. It goes into 240, leaving you 19, and 3 doesn't go into 19. And 11 goes into 222, leaving you 47, and 11 certainly doesn't go into 47. So we get b equals 259 over 33. Okay, now we hope this is correct. Well, what we do next is we take this value of b and this value of c, and we plug it into any one of our three equations. Okay, so I'm going to plug this in here, and I'm going to take this one and I'm going to plug it in, that's b, right, for b. And then from this equation, I get the equation 4a minus 5b, plugging in the b value, 259 over 33. And then it's plus 6c, 6 times 40 over 33 equals 9. Okay, well, numbers will get kind of big, get a little harder to manage, but you know, you've got to live with it. This is the real world. Okay. Multiply everything by 33. We get 132 A, okay, minus, I'm going to write it all out, 5 times 259. And there's steps that I'm leaving out that you should be putting in until you're totally comfortable. Because if you're not putting in the steps, chances are you're going to get around to a solution and you're going to find when you check it that it's wrong, and then you got to go to a whole lot of trouble. Okay, anyhow, okay, that 9 times 33 is 270 plus 27 is 297. And I hope I've got all those numbers right. And now we have just numbers with a multiple of A. So that becomes 132A minus 5 times 250 is 1250. 5 times 9 is 45, so that should be 1295. That's 240 equals 297. Okay, well, okay, 1295, negative 1295 and 240 is negative 1045. So that 133A equals 297 plus 1045. I hope I'm not making a mistake. 133A, that's going to be 42 is going to be 1,342. So that A is 1,342 over 133. 132. Where did I get 133? I started writing that here about the time I said I hope I don't make a mistake. Okay? Well, there we have the solution. Now this can be reduced. We probably want to do that because next thing we're going to do is we're going to plug A, B, and C into one of these other equations and see if it works. If it does, then we're pretty sure we've got a solution. Not 100% sure, but we're pretty sure. Okay, well, let's see. Does 4 go into 1,342? I think not, because 4 doesn't go into 142. So I think this reduces to half of this is 650 plus 21 is 671. And, you know, I'm really kind of extending myself. There is an increasingly high probability that something's going to be wrong here. And I don't mind that because we need to demonstrate the process and what's going to happen if something does go wrong, which is basically got to go back and excuse me, reinvent your solution. Okay, so 3 goes into 660, but that would leave 11. So 3 goes into 66, but not this. So there's a factor of 3. That doesn't work. 2 doesn't work. So you're left with 11, and 11 goes into it. I'll be darned. These numbers are just random, you know. Just 11 goes into 66 6 times. 11 goes into 671. Well, it goes into 666 times, and in the remaining 11 once. So it looks like A equals 61 over 6. Okay. Turns out I might want to digress at some point and talk about reducing fractions like this. Now, what I see a lot of is people going to their calculators and rounding this off as a decimal. Okay, and that would be 10.1666666. You round it eventually off to 67. That introduces a round-off error, and that might or might not be a problem, but at the level of pre-calculus, you got to be able to do basic pre-algebra arithmetic. Okay, basic 6th grade arithmetic, including fractions. So I will vastly prefer exact solutions. When I ask for an exact solution and you give me something you rounded off using your calculator, you're not going to get full credit. You might not get a huge penalty, but you're not going to get full credit. Following the rest of the procedure, though, it'd be kind of unfair for me to really nail you with that. So in a 10-point problem, you might lose 2 or 3 points if you don't give me an exact solution. Okay, well, okay, now we've got our solution. We need to check it. So let's plug these numbers into the second equation. Now, I'm not going to draw the arrows because the board is getting too complicated with arrows. But I take my second equation, and I'll note that there. It's 3a, okay? Well, let's see, a was, well, there it is, 61 over 6. I'm going to be kind of surprised if this works out. But then plus 2b, and 2b is 2 times 259 over 33. And it's minus 2c. I've got to be more careful because this thing really blues bad about smudging. My writing's hard enough to read, and might as well keep the board as clean as possible. Okay, so it's minus 2 times c, which is 2 times 40 over 33, and that ought to equal 4. I'm just going to make a ballpark estimate to see if I think there's a chance that this is right. That's about 30, and we're already messed up because that's pretty big, and that's pretty big. Are any of these things negative? I'm seeing no way this is going to come out, because this is only a little over 2. 40 over 33 is just a little over 1. So something I already see is wrong, okay? This is going to be like 30. This is going to be like 16 or something like that, minus 1. It's not going to equal 4. Now, normally what I would do is multiply by a common denominator, which in this case would be 66. And I'd get numbers that they aren't going to add up. So there's something wrong with my solution. So now I've got to go back and debug my solution, see what it is that could possibly have gone wrong here. And I already see something really, really bad. I wrote this as negative 33c, but it's 52 minus 19. That's positive. I made a mistake right there. I didn't try to make that mistake. I wrote it down carelessly because I'm inherently careless. Okay, so anyhow, this ought to be then negative 40 over 33, which is just negative 40 over 33. So that should have been a negative 40. So this should have been a plus 4 times 40. So this should have been plus 160. And then I'd have to subtract 160 from 99. And that would give me, let's see if we can do this halfway neatly. So this is going to be wrong. This is going to be wrong. I'm still going to have a denominator of 33, but my numerator is going to be all messed up. And most everything I did over there is going to be wrong. Okay, so I'm going to subtract the 160 from 99, which will give me negative 61. And, you know, I do want to do that, but not in this step. 3 times 33 is 99. I didn't need to erase that. And I get then negative 61. So this is negative 61 over 33, which means that I have to go up here and change this number. Okay? So, let's see. That's 259 over 33. So the number I need to change this number, this number, this number, and then this number is going to change. And of course, all this is going to change. So I'm going to just kind of wipe this stuff out. And this number's not going to be right. This number's not going to be right. And this numerator's not going to be right. Neither is this one, and I have no idea what I'm going to end up with there. But I'm probably not going to have the same unanticipated reduction. So, I'm correcting. Okay, I've got the negative 5b, but now b is negative 61 over 33. And let's get a matching color. That's not yellow. Okay. And then we get plus 305. And then the 240 is still okay. And it's plus 305. Actually, here I didn't do the multiplication in this step, but that'll be okay. So it's plus 305. So when I subtract 305 from 297, well, minus 305, and that is just negative 8. So A is going to be negative 8 over 132, and now 4 goes into both 8 and 132. So A is going to end up being negative 2 over 33. Okay? So that's going to help. That's like 2 over 33, and this is like 61 over 33. Then that's going to be a small number. That's going to be, that's still going to be messed up, isn't it? Because these numbers then all going to be negative, they're not going to add up to 4. Well, okay, I'm not going to go any further with this on this video, but I'll fix it and do another short video to see where my latest mistake might have occurred.